So today we will see how we can implement a stack using linked list. We know that stack is a linear data structure which follows a particular order in which the operations are performed. The order may be last in first out or first in last out. Mainly three operations are performed in the stack, and that is we are going to implement these operations using linked list. First one is push. We know that it's adding an item into the stack. If the stack is full, then it is said to be an overflow condition. Pop. It removes an item from the stack. The items are popped in the reversed order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. So this is underflow condition, and we are also doing one is empty condition whether the stack is empty or not. Turns true if the stack is empty, else false. Now let's see a stack example, a list stack example. Here is a C code showing a push operation. So before starting the code, the top variable should be set as null, and then execute push 6. Then a node for 6 will be created because this is a linked list implementation. So a node is created for 6. Once the data is stored and its address is made as null because this is the first element. So when it becomes the first element, then top should be pointed to 6. So that is top is now 6. Now another operation push 1. Push 1 is executed, and then 1 is the node 1 is created, and this address part should be pointing to 6. So because after 1 it is 6. So in this way it goes on. The address is pointing to 1 and pointing to 6, and now the top should be made pointing to 1. So now top is 1. Then let's see what is the next code. Again push 7. So a node 7 is created, and the address of 7 is pointing to, or the address part of 7 node is pointing to node 1. Now we want to make this top pointing to 7, and then we will be doing a push 8 also, and that 8 is created, and the node is pointing to the previous node 7, and then top is also pointing to 8. Now let's see what is the next operation. So this operation is pop. So what is the operation of pop? We want to remove the item that is the topmost item of the stack. So which element is pointed by top, that will be removed. So before freeing that node or before removing that node, we want to uh, remove all the links pointing to 8. So the link pointing or the address of that 8 is stored in top, and that should be pointed to 7. Then only we can remove this node. So that is 7. Top is now pointing to 7. Now it is ready to perform the or free operation on 8. So that is 8 is removed. So if you are not doing that, top is not reset to 7. While performing the free operation, this top link also get removed. So that should not happen. So before doing the free operation, we have to reset that or reassign the stop to 7, and then perform the free operation on the node 8. Now that is removed. Let's say the implementation or the code. So I'm defining a structure stack node which contains two parts, data part and next. That is star next. It is a next pointer variable. It is used for storing the node information, as that node itself contains another data and another next. So it will be self-referential structure. Another variable, top is a variable used for denoting each and every node or the topmost element of the stack. So initially that is also a pointer variable of type struct stack node, and it is set as null first. Now let's see is empty function. If the top equal to null, then we can definitely say that the stack is empty. So in this case, 0 is returned if the stack is empty, 1 is returned if the stack is not empty. So let's see the push operation also push of int value. Value is the data to be inserted into the stack, and when the value comes, there should be a node. This since this is a linked list implementation, we have to create a node, and some memory should be allocated dynamically using the function malloc of the size struct stack node. So that new node is created, and then value will be inserted into the data part of the new node. And we want to check whether that is the first node. So it is so the whether the stack is empty initially, then that new node's next part will be set as null. Then make that new node as the top. So that is the insertion process. That is, I am calling a push operation. Then a new node is created. This is a new node, and the value is inserted. If 8 is the first element or push of 8, I want to check whether the stack is empty. If the stack is empty, that means this is the first node. So if this is the first node, then I want to make this as null. So that next part is made as null. No new node's next part is made as null, and then that node should be made as top. So this is the top. So that is new node is set as top, and that insertion is success. If another element 9 is also pushed to the stack, push of 9, then another node new node is created. Now the new node is 9. This is the new node, and 9 is inserted, and its next part, what is the next part? It is the current top. So that is the current top is 8 now, and that is pointing to 8. So the new node next is the top, and the operation is not over. What is the next operation? We want to make this 9 also the top of the function. So this link is changed to 9. So that is new node is set as top. That is this operation. New node is set as top. So this is how push operation. So the insertion is success, and this process continues for every push operation. Now let's see pop operation. We want to check whether the stack is empty. So if the stack is empty, then we can display the message. Then we will be doing the pop for the topmost element of the stack. So this is a stack. I'm having 8 here. That is null first element. Then I'm having 1 here. It is pointing to 8. So now the top is 1. Simply I cannot delete top here, because top should be pointing. If once delete operation is performed, then top should be pointing to 8. So that is the algorithm of stack. So we want to point to the topmost node with another variable, that is temp. So that is shown here, and start temp, and that is also pointing to top only. Now before perform the free operation, just to display the temp's data on the screen. So the deleted element is 1, that is displayed on the screen, output screen. Deleted element is 1, and then make this link or cut this link. This link should be cut, and it is pointing to 8. Then perform the free operation. So top is equal to top or temp next. So temp next is 8, and that is 8 is now the top. Next perform the free operation. So This node is deleted from the stack. So now top is 8. And this process is repeated. And again checking whether the stack is empty. It is not. Again temp is equal to top. And again 8 is displayed onto the screen. 8 is displayed onto the screen. And then top is equal to temp next. Temp next is top is equal to null, become null, then free temp. So that 8, this node also will be deleted. And again checking whether this is empty or not. If the stack is now empty, so it will display that stack is empty. This is how pop operation is performed. Now let's see display. So in the case of display also, we want to traverse each and every node and display onto the screen. So whatever node is there, this is null. This is the node that is pointing to 8. This is top, and this is temp. Temp is also pointing to top. So we want to perform the display operation. So moving temp through all the nodes until the temp is null, then we will display that on the screen. So temp is initially top, and we are checking that where the temp next is not null. That is, one is not null, then display the data on the screen. So the output screen will be displaying first element 1, temp data, and pointing it as arrow. This arrow shown here. This arrow is shown here. And then we will be incrementing that temp. Temp is pointing to temp next. So temp is now temp next. So this temp is directly pointing to 8 now. Again checking for the while condition. Temp next not equal to null. So this temp next is not null. 8 is, sorry, 8 temp next is null. Now exiting from the while, then it is seen that the temp data is displayed on the screen. So that temp data is 8, and 8 along with 8 some lines, this message is printed. So that is the last element. So dash dash null is displayed on the screen. So now the temp becomes null, so it is exited from this display. Now in the main program, we are using a menu to do this stack operation. So using the do while, we will be creating a menu, and if you are entering the choice 1, then push operation will be performed, and if you are entering 2, then pop operation will be performed, and third display, and fourth one for exit. So that is the main. Using the switch case, we will be controlling the choice. So the case 1 will be push operation, enter the value to be inserted. So that value is entered, and then push operation is called. Case 2 pop and case 3 display. So while entering 4, then we will be exiting from the code or the program. We will be exiting from the program. Now let's see how this works. Let's see the output of this program. So this is a code I have copied into the online GDB compiler. The stack node is created. It's defined, and the top variable is empty push. Pop operation and display main code. Now let's see run this program. You can see the menu here. Stack using linked list menu is shown, push, pop, display, exit. I'm entering the choice 1. Enter the value to be inserted. I'll be entering 8. Insertion success. Then I'm again entering one more push. Then the value to be inserted 10. Then just display that stack contents. So choice 3 is entered. And we can see that 10 is the topmost element. Then 8, then comes 8, and that 8 is pointing to null. Then again one more push. So I'm entering 12. Insertion success. Let's display that stack contents once more. Now we can see 12, 10, 8, null. 12 is the topmost element. Now enter the choice 2. So that is for pop operation. So the deleted element is 12. Just display it. Enter the choice 3. So now 12 is popped out from the stack. Now the top is pointing to 8. So again performing once more. Pop. Deleted element is 10. So choice is entered 3. So 8. 10 is also deleted, and 8 is the last element. Again, I am entering a pop operation. So the deleted element is 8. Now let's display it. The stack is empty. So all the elements are popped out on the stack. So that is a program for stack implementation using linked list. Then entering the choice for exit 4. The program is finished. Okay, that's all about stack implementation of linked list. Thank you.